Now we're going to take what we've already learned about amplitude and period, and now we're going to look at what we call phase shift. Phase shift is just going to be the change in our horizontal position, so moving left and right. So when we look at our general form of our equations for sine and cosine, which we've looked at multiple times now, the formula for our phase shift is going to involve the c. It's going to be negative c over the absolute value of b. So on this first example, if I were finding the phase shift for y equals sine of 3x minus pi over 2, all I'm going to do is take my c value. Notice my c value is pi over 2, or negative pi over 2. So then I'm going to go ahead and say negative c then over the absolute value of b equaling 3, is going to be a negative pi over 2 all over 3. Well, that's going to look weird. So right away I'm going to say when I say over 3, or over absolute value of 3, that's the same thing as saying dividing by 3. Well, I know that dividing by 3 is the same thing as multiplying by its reciprocal, so I end up with pi over 2 times 1/3, giving me a phase shift of pi over 6. So what does that mean? Well, that means instead of starting at an x value of 0, I'm going to shift right a distance of pi over 6, and that's where I'm going to start when I graph this function. So, oftentimes associated with the phase shift is the new interval. The interval is just going to be where one period starts and ends. So we're going to take our typical interval, which starts at 0 and goes the distance of our period, whether that's 2 pi or something else, because there's a b that changes our period, and we're just going to add our phase shift to it. So let's go ahead and look at this example. There's two examples, I believe, maybe there's three. There might be three examples in this video. We're going to find the amplitude period, space between points, phase shift, and our interval. Then we're going to use that to graph this. So I'm going to go ahead and I'm going to find each of those things. So I know my amplitude is always absolute value of A. Whoops. So amplitude, and I'm going to go ahead and just abbreviate, is going to be absolute value of 3, which is just 3. And then I'm going to go ahead and say my period, and I probably should be putting my formulas in here so I can get those down. It's going to be 2 pi over the absolute value of b. Well, I notice that b is always the coefficient of my variable, and since it's just a x, my period ends up just being 2 pi. Remember, the space between points is going to be whatever period I find divided by 4, so because I'm essentially going to put 4 points to complete one cycle. So 2 pi over 4 is going to give me a distance of pi over 2. And now finding my phase shift, I'm going to use that new formula we just looked at, where I'm going to go ahead and take negative c over absolute value of b. My c kind of looks like an s there. So my c is pi over 6, so I'm going to have negative pi over 6. We already talked about how b was just 1, so my phase shift ends up being negative pi over 6. And lastly, I'm going to find my interval. So my new interval is going to be 0 plus negative pi over 6, comma, my period, which is 2 pi plus negative pi over 6. Well, that means my interval is going to be negative pi over 6, 2 pi plus negative pi over 6. I found a common denominator, and I got 5 pi over 6. Please let me know in class if you are struggling with putting those fractions together. Now I'm ready to graph. So I'm going to go ahead and I'm going to label my axes on my graph. Now that I have my labels, and I'm going to go ahead and start. So normally I would start, so it's sine, I would normally start here and say sine starts at 0, 0. But according to my phase shift and my new interval, I'm going to start back at negative pi over 6. Well, if you look at your unit circle, pi over 6 is kind of that first angle that we look at in quadrant 1. Pi over 6 is just barely past 0 degrees. So negative pi over 6 is going to be just barely behind 0. So I'm going to go ahead and go just behind 0, and I'm going to put my first point. From there, my sine function travels up to 1, but because my amplitude is 3, I'm going to travel up to 3, and I'm going to go a distance of pi over 2 to get to that 3. So distance of pi over 2 would put me just behind pi over 2. And then I'm going to go another distance of pi over 2 and go back down to 0, putting me just behind pi. Another distance of pi over 2, putting me just behind 3 pi over 2. Another distance of pi over 2, putting me just behind 2 pi. And notice that now I'm restarting. I've completed one cycle, and I'm about to restart another one. Where did I complete that one cycle at? I completed it between negative pi over 6 and 5 pi over 6. Remember, 5 pi over 6, I can either look from here or I can look at my unit circle. That's just behind 2 pi. And notice I am ending just behind 2 pi. So now I'm just going to go ahead and add a couple more points in to complete that second period. So again, I'm going to go over pi over 2. And I'm going to go back pi over 2. I'm going to go back pi over 2. I'm going to go back pi over 2. Back pi over 2. And so here is my completed curve, taking everything into account. So let's go ahead and look at another one of these. So notice the first thing I'm going to do again is I'm going to find all my information. This question is going to be very similar to the last. And I do have two examples. I'm going to put them both on the same graph. Please make sure you watch the second one. The third example is a good one for you to try if you feel like you've got it. You don't necessarily have to continue watching for that third example. It's going to be very similar to this first one. All right, so I'm going to go ahead and again find all that same stuff. So first thing I'll do is I'll find my amplitude. And I'm using this function here. Notice that I don't have a value out front, so my amplitude will just be 1. Then I can find my period. So period is 2 pi over b, so I'll have 2 pi over 2, so pi. So it's going to take me less time to complete a cycle, so I should have that skinnier looking graph. It should look like it's smushed in from both sides. So from period, then I can find my space between points. And it's going to be just taking my period and dividing by 4, so every pi over 4, which is halfway between, it's half of a pi over 2 increment. I can see that from my unit circle, or I can take 1/2 times pi over 2. So there's my space between points. I'll find my phase shift by taking negative c over b. And then I'll find my interval by doing 0 plus pi over 2 and 2 pi plus pi over 2, giving me an interval of pi over 2 to 5 pi over 2. And again, where did that 5 pi over 2 come from? I got a common denominator. So now I'm going to go ahead and I'm going to label my axes. Now that I have my axes labeled, I'm going to go ahead and graph. So instead of starting at 0, so cosine normally I would start at 0. Oh, this is sine, excuse me. Sine I would normally start at 0, 0. But notice I'm going to shift over and start at pi over 2. So I start at pi over 2. Sine starts with a y value of 0. My amplitude is 1. So now I'm going to go over pi over 4. And then put my next point. So going over pi over 4, notice that each of my my intervals here are pi over 2, so pi over 4 is going to be half of that interval. So I'll go over pi over 4, put my next point. I'll go over pi over 4. I'll go over pi over 4. I'll go, and I did not go down all the way to 1 because I go over pi over 4. And notice I'm now starting to repeat my cycle. So here is one complete period. And notice it is occurring between pi over 2 and 3 pi over 2. And I apologize because that was supposed to be pi plus pi over 2. So this is 3 pi over 2. I failed to use my new period when I calculated my interval. So there's my true interval. And now I can continue and I can sketch my second period. I can go over pi over 2, over pi over 2, or excuse me, pi over 4, over pi over 4. And notice I could also go back if I wanted to. Again, I want to go ahead and look at one more example. Again, this would be a good one for you to try before I go through it to see if you've got it. I am going to go ahead and put this on the same graph. So I'll change my color here. And I'm going to go ahead and do the same thing. I'll start with my amplitude. The number out front, since there isn't one, my amplitude is just 1. Then I'm going to go ahead and find my period. 2 pi over absolute value of b. So notice x over 2 is the same thing as 1/2 times x. So my b is 1/2. So my period is going to be 2 pi over 1/2. Well, right away I'm going to say, hey, over 1/2 means divided by 1/2. Then I don't have that funky double fraction. That's then the same thing as 2 pi times 2, or 4 pi. So notice it is taking a much longer time to complete that period or complete that cycle, so it should look a lot wider. Then I can find my space between points by taking my period and dividing by 4, giving me pi. I can also find my phase shift by taking negative c, negative pi over 4, and dividing by b, which we decided was 1/2, so I divide by 1/2. That then gives me pi over 4 times the reciprocal, or 2. 2 and 4 reduce, leaving me with pi over 2 for my phase shift. So notice my interval, squeeze this down in the bottom, is going to be 0 plus pi over 2. And then I'm not going to make the same mistake I did last time. I'm going to take my new period and I'm going to add pi over 2 to that, giving me an interval of pi over 2 all the way up to 7 pi over 2 after I get my common denominator and add there. So now I'm ready to graph. I'm going to extend this a little bit and say this is then 7 pi over 2. And now I've already got my axes labeled, so I'm ready to graph. So it's my sine function. So normally I would start at 0, 0. But according to my phase shift, I'm going to start at pi over 2. So I'm going to put my point at pi over 2, very similar to the last curve. However, now I'm going to move a distance of pi before I put my next point. So going over a distance of pi, I put my next point. Going over a distance of pi, I put my next point. Going over a distance of pi, I put my next point. And notice that this is going to be, I am looking at my graph and saying what's wrong here, and I realized that when I did my phase shift, I lost my negative. So this should have been negative pi over 2, this should be negative pi over 2. I really don't want to redo this whole video, so I'm going to go back and I can't just erase those individual points, so I'm going to change my color and I'm going to regraph this. So with my new phase shift, and I do apologize for that in my new interval, I should not have started at pi over 2. I should have started at negative pi over 2. And I knew that I had an error because I knew my interval was supposed to stop at 7 pi over 2. And so when I didn't have a complete interval at 7 pi over 2, I knew there was an issue somewhere. So I'm going to go back and regraph correct. So I'm actually starting at negative pi over 2, going a distance of pi, and putting my next one. Going a distance of pi. So again, ignore those blue dots. I know that's confusing. Going a distance of pi, and going a distance of pi. So now when I check, notice that I do complete one interval in what I predicted. I could do another one by going back a distance of pi, going back a distance of pi, going back a distance of pi, and I don't have enough room on this graph to complete the whole interval, and I believe for that reason I anticipated it by telling you just to graph one period, but this is what it would look like. Again, I do apologize for those mistakes I kind of made throughout. Hopefully you were able to follow along and kind of adjust your work and fix as we went through it. If not, please make sure you're talking to me about that in class so we can get that cleared up.